G'day everybody and welcome back to the channel. I just want to point out before I get started on this video, I forgot to add some protection diodes between the base to emitter junction on this comparator transistor. Because the emitter goes straight to the negative terminal, if a positive going spike comes back up the negative terminal of the power supply, it can damage the base to emitter junction. So 4 diodes is enough. Well, it was in my other supply that I used a similar topology for. Like it has a single transistor acting as a comparator. It has a lot more support circuitry driving that transistor, but at the heart of it, it's one transistor as a comparator. If I remember correctly, 1N4 and 4/8 was enough to not have an influence on the transistor basically. But whilst, you know, being well away from the emitter to base breakdown region. So I've added them. I drilled a hole there and there and soldered them in. So that's now the whole board without the compensation components. What we're going to do now, I'm going to show you how we put a plug on a cable in Australia here, and then we're going to put this, well, not in the supply, we're just going to hook it up to the supply, hook the scope up to the output, add the output capacitor, the output load resistor, and then we're going to start with all our compensation networks and stuff like that. Alright, so if we take a look at the back of the packet, what you'll find on pretty much all plug packets that aren't some knockoff Chinese thing, like this is made in China and it's a cheap crappy one, but it's still you know, passes standards, safety standards. Anyway, so we need 45 mils plus 6 mils, so 51 mil. So we have to strip 51 mil of cable back, like so. Haven't got anything in here. It's really good for this. I wouldn't recommend doing it like this, but if you're used to your tool, you can get away with it. You know what? I lost my 51 mil mark. Doesn't have to be perfect, you know, 52 mils will be fine. 50 mils will do it, you know. The problem is with these tools is you can nick the wire by cutting in too far. I should have just scored around it with something, but oh well. This is an old lead from like, I don't know, the 80s or something. So it's got a thick, not thick, a stiff outer jacket. Alright, well at least I haven't nicked my wires, so that's good. Anyway, 6 mil you want to strip, that's, you know, just over a centimetre. Honestly, you don't really need to measure it, you can just do it by eye. Well, that's not long enough. I loosened my strippers up a little bit too much. Well, that's 6 mil. That's better. Wow. I wonder how that wire is so oxidized. The reason I say this is because this had a terminated plug on it, and as you all saw in the first video, I had cut this open and broken the earth wire out so I could break the earth on this supply. And the earth wire is shiny, but the one I didn't cut is oxidized. Now that means one of two things. Something corrosive got in at the power supply end and wicked its way all the way up the wire, or at the plug end. Neither of which is very likely. I mean, the power supply end makes more sense than the plug. What? What? Tell me you've seen that before. And I don't mean, I've had my cats piss on cables and stuff, and like I said in another video, cat urine is very corrosive. But, what, just active and neutral but not the earth? What? I am bewildered. I don't know what to say. I honestly don't know what to say. The weirdest part is the copper's really healthy. It's like it hasn't oxidized past like a micrometer, if that makes sense. So I've stripped heaps of cables that have been corroded, some from my cats, and the copper breaks down too. It doesn't just turn black. But this is like, the copper's still shiny and thick, and there's no mess in there, but somehow it's got a black sheen on the outside of it. This is a weird one. I should really change this cable. Just looking on the cable for nicks, because my rabbit, I don't have rabbits now, but I used to have 2 rabbits, and they did a lot of this to cables. And I think I've just found, okay, so this makes sense. There's a nick in the blue wire that goes through the insulation there. Okay, so I didn't notice that. This cable's going to have to get changed. All right, well, for the sake of the video, I was going to say I'll just go grab a cable with a plug already on it, because I've got plenty, but for the sake of showing everybody how we wire up a plug in Australia, I'll still just do it with a normal piece of cable. That means the back's got to come back off of this again. Bloody hell. Alright, it is what it is. I'll go reset up. Alright, I've put the phone in the tripod because it's very awkward to get the back off of this thing and get you guys a view at the same time. First thing I need to do, wrong tool. The annoying thing about this is the neutral wire goes straight to the transformer, and it's in an impossible location to get to. And if you were to take the transformer out to get to it, you'd be having to cut out the wires that go to the fuse holder. I'd have to redo the power switch. I can tell you now what I'm going to do is the brown wire, active wire, goes straight back to the fuse holder over here. I've already resoldered this one and heat shrunk it. I'll solder the brown wire there. I'll solder the earth wire where the earth wire goes. And the blue wire, I'll just join that with some heat shrink, and I'll tuck it where this little piece is here that holds the wiring together. I'll tuck that bit of heat shrink where the joint is down there. That'll only be held against the frame, and the worst possible case scenario, if it's not like it would actually happen anyway, but I'm just saying, even if it could, and the solder poked, hello little man, the solder poked through the heat shrink, you know, it would only be hitting the chassis, because that's what it'd be clipped against. So that's what I'm going to do. I know it's a little bit lazy, but again, it's only my own supply. It's not like I'm doing a repair job for somebody. If I was doing a repair job for somebody, you know, I'd be doing it properly. Ah, got it. Getting those cable glands out can be quite tricky sometimes. What you need to do is you need to put force down on this piece and squeeze the absolute living crap out of it, and then you can get it to pop out, and to open it just opens like so. Alright, I'm going to go get another piece of cable. I'll be back in a moment. Alright, I've run into a small problem, and I'll just show you so you know I'm not making this up. All the cables that I've got lying around either already got plugs on them, or they're really small bits that are too short, or wait, I think I might have just found one. We might be in luck. I was going to say, I don't want to use a cape. No, that's also 1 mil. I wanted a 0.75 mil cable. I don't need anything that's bigger than a 7.5 amp cable, and I'd rather keep all my 10 and 15 amp cable for high power stuff. So unfortunately it looks like this is the only long lead I've got that's 0.75 mil. So we're going to be using that, and we're not going to be wiring the plug up. Sorry about that. We're not going to be wiring this plug up in this video, but I do have plenty of projects to build, and I can tell you now, some of my projects are going to have pretty high current requirements. So this plug will get wired up in an upcoming video within the next month, I'd say. I've got amplifiers, power supplies, all sorts of huge things. I've got a huge switching power supply to finish off, and that needs a 10 amp lead on it. Oh, sorry about that sound. So yeah, don't worry, we'll still wire the plug up, just not in this video. My apologies. I'll get the camera back. Hold on. Alright. Yeah, I'm not going to lie, I couldn't be bothered at all having to wire up a plug. But I wanted to do it for you guys, for people who don't live in Australia and are just curious how we wire up our plugs, and for people who are learning electronics that want to know how to do it properly. So don't worry, I'll do it in a very soon upcoming video. This one I'm just, how much wire do I need? Alright, that's interesting. I'm just gonna cut little bits around it in a circle fashion like this. This is much quicker and easier than using the wire stripper tool. Like so. I'll just get that powder off the wires. Yes, that's supposed to be in there. You'll find in some cables, others you won't. It doesn't mean something's wrong. Alright. Let's see how these wires look. I can already tell looking in the end that they look good, so. Yes, copper. Well, it wasn't the earth wire that was the problem, was it? Copper. Copper. We're in luck. The only reason I stripped the wires before putting it through the cable restraint and into the thing, honestly, was just to make sure that they weren't black. I've had terrible luck with the cats coming in here and pissing on my cables. I'm not... Good thing this is old school tech that can handle being thrown off a cliff, eh? I'm not exaggerating. This just happened this morning. I'm going to have to get the light on my phone. You may note they kind of dried already. No, you can see the moisture in the box, can't you? I had to just wash all these cables. One of my cats came and pissed in it, and this is all shielded cable. Every cable in this box is shielded. There's everything from RJ58CU to audio cable, some with 2 wires and a shield, some with 1 wire and a shield. Little other styles of coax, like not RJ58CU, like small 75 ohm stuff and higher frequency stuff, and little Wi-Fi antenna bits of coax and 2-core shielded cable. All my shielded stuff's in there, and then the cat went and pissed in it. That's RG174. Anyway, I don't need all my good coax getting ruined with cat pee, so as soon as I noticed that, I grabbed the box and washed it all off, gave it a quick dry up. But yeah, it's the absolute worst when they get in here and do that. I don't know what it is about boxes of wires, but they seem to think that a box of wire is a toilet. I think it's because you can sort of scratch around in it, like they do with their dirt box. Just a tip, when you get one of these back in, give it an initial push down on the cable to get the cable squeezed in there. That'll give you a bit to work with. Again, annoying that I had to strip the wires first, and I know you can't see what I'm doing right now, but you will in a second. There you go. I assure you this is extremely, extremely awkward trying to do this like this. I think I might just have to do this off camera, I don't know. I don't know if I can get it in there like this. Yeah, I'll just pause the video and get this in. It's just going to take too much force and there's no way I can get the camera on it. I'll be back in a moment. Alright, I got that in. That took a little bit of wrestling, but it's in. So, what I propose to do, I'm going to move this rubber mat across because I can stop it from slipping like this. Much better. You hear that kid riding around the 2-stroke engine? I've got a bike that, it's one of those Chinese 69cc engines, right? I milled the crap out of it, balanced to crank, opened the ports up, bigger intake, built an expansion chamber for the exhaust, put a bigger carby on it, the whole lot. I even took the head off and took about a mil off the head and built a squish band into it too. I go nuts when I build engines, and I got the thing doing like, it was 80 or 90k, 1 gear, 2-stroke. Man, I got that thing moving fast. Anyway, this local kid's just obviously got one, but it's stock. Oh man, that's terrible the way they come out the factory. The motors aren't balanced. Everything's wrong. Like the port durations are wrong. The size of the ports are wrong. Even the machining, there's all rough burrs and stuff on the inside of the ports in your sleeve. The rings are crap. Some of them come with a nice heat-treated conrod. Others come with weak as shit conrod. Some come with really nice sleeve bearings. Not sleeve bearings. You know, the 2 types of bearings you can put on the bottom end of a conrod. One's crap and one's good. I can't think. But yeah, most of them come out with crap parts and they're not built very nice. Let's just leave it at that. Anyway, yeah, this kid's riding one around and it just makes me cringe just hearing that poor motor just, if you've done enough 2-stroke, just nix that blue wire. But I didn't go into it. You know what? I just started to. I'll put a bit of heat shrink around that. Damn it. Anyway, it just makes me cringe just hearing a motor run like that. If you build motors and you know what a motor should sound like and you hear something unbalanced, just tearing itself apart to pieces. I mean, I hear that going up the street and all I hear is just piston rings getting torn to bits and bearings just getting eaten up, you know? It's just, yeah. I would have thought after all these years of them making those bikes that they'd refine them over time and make them better, but that's the thing. Some companies make a decent kit, other companies make a crap one. Oh, I need to shorten that up. I wasn't thinking there. That's my problem once I start talking. I don't think. There's also companies that for a ridiculous price offer aftermarket parts to do your motor up, and it's ridiculous. I mean, they make all these fancy looking heads and this and that, and I can tell you now from building my own, it doesn't matter if you get the fancy head or if you take the stock head, build a squish band into it and take a mil off it, it's the same as the fancy head. The fancy head might have a bit more cooling room on it, so it might be able to run a little bit cooler, but I forgot the heat shrink. This is what I'm talking about. It certainly isn't worth, I'm not kidding you, I've seen kits that are thousands of dollars, starting at like, 600, going up to like thousands of dollars for the, whatever they call Mark 5, Mark 4, Mark 3 kits. They come up with all different, try and make it sound like it's something special. And all I did with mine was, I remember the conrod was a ZAF 80 conrod I used. I balanced the crank myself, literally drilled holes through it, and then countersunk the ends of the holes so that they weren't rough, just to try and minimise the effect on foaming oil, if you're wondering. What else? I know I put all better bearings in it. After I upped the compression on it to a ridiculous amount and balanced it, ported it, polished, all that sort of stuff, intake, exhaust, expansion chamber, I remember one of the seals on, I can't remember which side of the engine it was, but one of the crank seals kept popping out, so I had to make a retaining bracket that would sit behind the magneto and hold the crank seal in so it couldn't pop out from pressure, because it's a two-stroke, right? So crankcase pressure. What else do I do? Oh yeah, aftermarket ignition with timing retard, because it's a two-stroke. I think it's retard. 4 strokes, I think timing gets advanced as you go up in RPM and power, and 2-stroke I think it goes down, but backwards retarded. I can't remember. I haven't played around with these things for quite a few years, to be honest. But I've still got my performance one that I built myself, all of everything, even the bike, not just the motor and the parts. And recently I got given to me one of the stock Chinese kits, which is awesome because I already had some other parts lying around, piston rings, bearings, conrods, stuff like that. And my one, oh damn, I shrunk the heat shrink. Stretch that back out. My one, I eventually, even though it was balanced and that, I was really running way too high compression on it, so it still ended up eating the bearing, which then obviously gave the piston sideways movement, and you guessed it, piston rings. So mine's been retired since then. It was actually quite funny when it happened. It lost the oil ring first, not the compression ring, and I couldn't work out what had happened at first because it was actually, it didn't sound any different, and it still had compression. You couldn't tell. I forgot about that blue wire I nicked. It's the smallest little nick in my defense. It's never gonna go anywhere. Plus it gets folded over on itself. Yeah, that's fine. Yeah, so it was acting like it had full compression. You couldn't notice it trying to kick it over or whatnot. But I took it out one night. I thought something was wrong with my carby at first. I thought it was just the actual air fuel ratio, like the carby was blocked up or something. And no, as I'm mucking around with the needle and seat, because I thought something was blocked in the carby, so I thought I'd just move the needle up a bit to let more fuel in to see if I had restricted fuel flow. And no, I started up, took it for a ride. It went a little bit better for about 2 seconds and then stopped. And then when I went to kick it over, no compression at all. Knew straight away what was going on. So, point is, I've got spare bearings. I acquired another ZAF 80 conrod. Not that I need another one, but I needed the bearings, and the one I got had the bearings in it, so that's why I got it. And what else? Now I've got this other motor, I've got a spare set of rings. Don't know what tensile strength they'll be. But point is, I do have enough to actually rebuild my original motor and get that back up on the road. The only thing I'm missing for it was a CDI that retarded the timing for it. I tried to use it on another bike, and the magneto put out, well, it wasn't that the magneto put out too high a voltage, it was me being an idiot doing stuff to the bike to get it to rev higher and higher, and obviously the higher it revved, the higher the voltage the magneto made, and it ended up cooking the CDI. So I don't have the CDI anymore. But the funny thing is, I actually took the stock CDI that came with it, and this is before I bought the aftermarket CDI, and I took the magneto, which has got a little woodruff key to hold it into position so that you can't muck the timing up, and I basically removed the woodruff key, and what did I do? I roughed up the surface of the where it mates up to the magnet, the spinning magnet itself. I roughed up the surface of the crank for the crank, and I roughed up the surface of the magneto. I got some locking nuts and two extra bolts so I could lock one nut up against the magneto, make it really tight with the locking nuts, and then another nut to lock that nut so that it couldn't come off with the motor running. And I was able to get the timing retarded to just the right amount, or I can't remember which way I had to put it. This was years ago, but I got the same performance out the stock CDI by just changing the positioning of the magneto in relation to the flywheel magnet, if that makes sense, to advance it. Or, oh my god, I've done it again. Yeah, you know what I'm trying to say. I'm just going to stop talking and just start working now, because I'm bloody terrible at working when I talk. Make a mess of everything. Jeez. Sorry, guys. Oh, I don't know why I'm apologising to you. It's probably quite hilarious for you guys. Not for me, because I've got to do it twice. Right. But yeah, hearing that kid riding his bike around does two things to me. It makes me cringe hearing that poor motor vibrating and the timing and everything on it, and trying to breathe through those little dodgy ass ports and intake tubes and everything. And it also makes me want to rebuild mine. You see what I mean about just linking the blue wire like that instead of trying to get in there and have to take all that out? That's fine like that. That's not going to cause a problem. Oh, well, there is an active wire next to it, but it's not going anywhere. Alright, I'm going to get this earth wire soldered down here. Tuck that over there. I don't know how we're going to get this off. It's probably wrapped through and through and through. Yeah. I think I see a solution. If you wonder why you've seen me twist wires in either direction, I try to go with the way that the direction the wire's already twisted in the sheath, if that makes sense. Yes. I was able to loop it around because it's still got a hole. Beautiful. Can't ask for more than that. Great, great. Well, that's that sorted. We have a power lead again that's not black. Come to think of it, my rabbits actually used to piss on things too sometimes. It wasn't just the cats. I mean, obviously now it's just the cats. I don't have rabbits anymore, but point being, animal urine. I suspect that's what happened here. I honestly don't know how they got to it, but that's the thing that baffles me. Oh well. It has a new lead now. Now we can get on with what we were going to be doing in this video. Right, so I'm just going to pause the video and blow my nose because I still have a cold. Alright, that's better. Let's plug my charger back in too. Right, so you know what? I'll just take all these bits of metal for the breadboard off and come back. Well, that's that done. I've got a cable tie here because I never found the bracket for the capacitor. I really want that in there. I'll cut these off of, well, you can't see. I'll cut these off of the LED because, as I explained in the last video, I don't want these oxidized old aluminium lugs in between the nice locking washers and the PCB because that'll have better contact resistance. Alright, so let's do this. So positive and collector, or positive and collector. So for now, because we need to just work out the compensation components, I'm just going to tack things on, leaving the holes free, ready for when we build it. Negative. Guess that's going to come in here. Now, orange is our collector, pink is our emitter. One of these is the base and one's AC. Alright. See if I can work out which wire's AC. Okay, this is the base wire. So this is our AC wire. These wires, the solder that's in them, it's gotten that old that it doesn't like to work anymore. I doubt it's lead free. Although, you know what? I've found older solder flows wonderfully. I've worked on boards out of organs from the 70s and everything, so I don't know what the go is with that. Must be just a different type of solder that they used for tinning wires. Alright, we've got our earth wire here and we've got our emitter wire, which is all we need left. Now what we need to do is we need to put our pot here, and well, we need a wire coming from here that sort of goes to our emitter, and then that will be going to one end of this resistor and the positive side of that capacitor, and then the negative end here needs to go to the other end of that. So basically, yeah, that's that. So I'm just trying to think the best way to do this. I think I'll just pause the video for a minute and have a think about this, because I want to set this up on the bench so that we can scope it, play with the board and all that live on the scope. You know what I mean? I'll be back in a moment. I'm just going to do this because that gives me a point to scope across. That's my emitter. Now all I have to do is run back to the board, the positive and negative sense lines, and add a pot to this, and we're good to go. So I'll get 2 bits of wire in the pot now, and I'll be back. Actually, we've got the pot in the front of the case. Although I don't want to waste bits of wire, so I'll just go get the pot. That's why I have this. This is what I was saying in an earlier video. I keep a whole random load of pots just in a container with wire attached to them for breadboards. You don't understand how handy this is for prototyping, because, you know, I want a logarithmic 5K pot right now. Just a 5K ready to go in breadboard. Just another little tip. I don't know, it depends how you build stuff. I'm the sort of old school person that likes to build stuff on breadboard. Like I said, I don't use CAD software. I try and make everything my own design. If I do need inspiration, I'll try and only take inspiration from someone else's design, but still have my own complete spin on it. I really find it works out for me to have everything ready to go, but you know, each to their own. You know what, I'll just tin these. Cool. That's our pot. Now we just need our positive and negative feedback, which just goes to there, and we have a supply set up. We can start working out components for compensation. Should be able to, excuse me, I should be able to just do this upside down like this because I'm pretty familiar with this now. I mean, I made the board up myself. The thing is, I find it, I always have, you know, probably because I started off making PCBs like this, so I'm used to looking at the top side, and I guess, I don't know, I find it's a little bit longer for me to not build the board because you still lay the circuit out the same. Obviously the components is going the other way around on the other side. But the thing is, when I'm trying to remember where things are, it starts to muddle my brain a little bit because I'm used to looking at the other side. But I'm pretty familiar with this one. I am getting good at it. So I know we've got our RC snubber across output to base of comparator there. We've got our comp cap for the Zener, or shut the hell up cap for the Zener there. And we've got the other shut the hell up cap for the other Zener there. And the other shut the hell up cap for the other Zener there. So I won't need to turn the board over. I'll go get 2 bits of wire to add feedback, sensing, whatever you want to call it. And I won't use this probe. I'll get one of my custom probes I can solder right up to that capacitor so you can get an accurate reading. And I'll be back. Okay, what we have here, sorry I couldn't help doing a Shango, is 2 little random bits of wire. This is obviously just for testing. So that's going to get confusing. Okay. Put our negative there, put our positive here. I'll just get something to put this on. It will make it a little bit easier. That does the trick. Move it back so you guys have got view. Is everything in shot? Alright, I think that's as good as I'm going to get that. Okay. Don't need that for this. Get a meter. Stick that on the output. Oh, I forgot my scope probe. Sorry guys. Alright, one scope probe. Oopsie, put the other one back in the wrong spot. Alright, I know I should have hooked this up off camera, sorry. So the idea with this is we don't have all the extra length, and that's the shortest ground loop you'll find. In fact, sometimes I've even been known to take that off and solder directly across the barrel and the tip. That's even better, but if you can't reach, you know, that's why I've got that little bit of wire on there. So I've still got that ground wire short as it basically is tip and barrel. Alright. The reason we measure across the capacitor is because the capacitor is going to be directly across. Oh, shit. Oh, no. Fuck. I just picked my chair up because the wheels are caught in this sheet that I got on the floor. And I waved the arse end of the chair, the wheels around behind me, and got it caught in my shelf full of projects. Not good. Alright, so I'll turn the power supply on. Let's see if it still works. Okay, that's not good. Not good at all. That's very bad. Nothing ever goes to plan, does it? Oh! Bummer. Something's wrong. What is wrong? Ah, I'm an idiot. That's absolutely hilarious. I've put my feedback for the negative and I haven't run the negative to the negative. You know, there's probably nothing wrong. Let's hope. Let's hope. Wish me luck. Just grab a random piece of wire out this box. That'll do. Oh, I can't believe I did that. What was I expecting? I must be turning into one of these free electricity people that with their one wire systems. Sorry, I couldn't help it. And before someone tells me to be careful about making jokes because I'll lose subscribers, I'm not worried if those people are subscribed to my channel and I lose them. I'd rather have people who actually understand what the hell's going on than people that think they know what's going on. Looks like the supply's working. Oh God, it's not working. I think, wait, what? Wait, have I put Zenas in the wrong spot? Wait, it only goes down to 17. Let me think about this for a minute. Should only turn up to 18. Okay. Well, at least it's not something critical that's going to pop transistors and all that sort of jazz, but something's amiss here. Let's test our Zenas. Or is it this? Maybe that doesn't work in this circuit because I've got the reference on the emitter. No, that's not going to make a difference. I've got a Zener in the wrong spot. I must. It's the only logical thing I can think of. You're kidding. No way. That's the 5.1 volt Zener. I'm sure of it. Oh no. So we've got the 5.1 that should be in the emitter path in the voltage doubler section. It is. Oh no, that's the capacitors charging up. Hold on. Ah, no. That's the 13 volt Zener. Wait, that doesn't really make sense either. You know what? Let's just do this the quick way. Because that Zener should be the 27 volt Zener. What? Okay, that is the 27 volt Zener. This Zener should be 5.1. What? Wait, it's the diodes. And this should be, let's see, pointing to positive, 4148 pointing away from positive. That's right. 1k resistor to the from the pot to negative Zener, that's correct. This should be 18 volts on it when we turn the power supply up. Huh. Oh no, that was a 12 volt Zener. No, that's right. 12. Because of the 5 beta E drops and the 1N4148 diode, that adds up to 18 volts. It's got to be these diodes that I added for base to emitter protection. I think I'm going to have to add a Zener and 114N4148 diode in between the actual reference too. Let's just see if I'm right. Or have I put a transistor in the wrong way? Let's just see. What? It's not the diodes. I didn't think it was because they're across the emitter to base junction. They're not anything to do with the reference. It's not like the reference voltage is dropped across the transistor. It's dropped across the Zener, and the transistor just drops in between 0.6 of a volt because it doesn't go into saturation, and whatever, what, 18 volts or something like that. What on earth is going on here? If I said to you I knew what was going on, that would be a complete lie, because as far as I can see, everything is right. Collector base emitter. I'm going to pause the video, have a look at my schematic, come back. I'm sure it's something stupid and small, and I wouldn't be surprised if someone's already noticed it and is laughing at me right now. Alright, well this has gotten very strange. I've gone over my schematic. There's nothing wrong here. Unless somehow I put something down on the schematic wrong, like in the feedback section maybe. That's the only thing I can think of. Maybe the pot goes across the Zener and diode, and then there's a resistor from that going to ground. I can't remember. But I'm just going to take out the comparator transistor, because when I powered this up with the negative disconnected, current could have tried to flow through the base to emitter junction and destroyed it. So I'm just going to swap it. Alright, that other transistor won't go to waste if this doesn't fix it. I'll leave this one in here. I'll just use that on another board. It's got plenty of length on it to go into a board. It won't go to waste. Alright, let's give this a try. Did I put that the right way? Yes. Hey, that's what it was. I popped the compare. Oh, you gotta be shitting me. What the? What is going on here? Nothing is wrong. I've traced the entire bloody thing out, and yet it doesn't bloody work. Oh, I hate these days. Alright, I'm going to have to work this out off camera because I don't want to waste everyone's time, but obviously something's amiss. I've even unplugged the scope just in case I hadn't unreferenced something to ground, but no, it's not that. It is my circuit. I'll be back soon. Right, I believe I fixed it. I'm going to have to change my schematic because I did do something wrong. I've had to add a link there and the resistor here and change the pot from the end of the track from there to there. Now that doesn't make any sense. I know that, so don't worry. I wouldn't do that to you. Quick question. If anyone has an answer for this, leave it in the comment section because I honestly don't have a clue how to do this. Is there a way I can edit the schematic that I showed in the other videos, because obviously this error is in those schematics, without having to like re-upload the video or lose the views or like just screw the video up basically? You know, like take it down, lose all the views and everything, stats for it, and then have to re-upload it as a new video. Is there another way I can edit that? If there is, could someone tell me? Because I'm sure I've seen stuff like that in other videos. Anyway, I'll show you what I did wrong. It's kind of comical. Quite literally. It's very simple. Can't draw with that. That is what I did wrong. I had the pot attached to the end of the diodes and the 1K in series of the pot. That's not how it goes. It goes like that. So I thought, I thought if I just showed it, it'll make a lot more sense to people than just trying to show you on the board the changes that I made. Now that I've shown that, excuse me, I still have a cold. I had this reach before. Right. Wish me luck. Let's try again. I haven't tried this yet. I am 90% certain, 99.9% certain that I've got it right. Hey, that's better. Are you fucking... What? Wait, so it turns down to... Wait, that's... Oh my god, that's right at the bottom end, but now the top end's not limiting. What have I done? Ah, god, one moment. Okay, I am really having a bad day today. I can already see what I've done. I'll show you on the schematic. I just made the schematic wrong again. This now needs to be moved here. Right. Jesus. So I don't need that link there. That link was just unnecessary. that can just come out. I'm not desoldering it again. I might when I assemble. I'll leave it there for now. I'll make it all neat and pretty when I go to assemble it. Anyway, what I just did, this is really dumb. Where is my eraser? I swear the stranger things happen in this lab. I just had the eraser here. It's gone. There it is. Okay, so what I just changed was this. Whether that was the problem or I've just made another error, we'll see in a minute. But I think that's right. I think that is right. The pot looks across the Zener and the 1K goes to ground at the end of the pot and the end of the Zeners. That does actually make a lot more sense to me now I think about it. Man. Hey, there we go. 5.8, 18. God, I am not proud of myself. Alright, so let's see what we've got for noise. We've no common mode filtering, which will knock off all the peak to peak. You know how it's going to be way better when we make this up. On breadboard we had about 11 millivolts, 12 millivolts peak to peak. We're down to 3.5 millivolts peak to peak. RMS, I'll just show you guys. Pretty good. All right. What I'm going to do, I'm going to go have something to eat because I'm hungry. Come back, set the camera up in the tripod so you can see the screen and this, and we'll experiment placing values of capacitors across different areas. But we're also going to use the other scope probe because we're going to want to look, say at the end of this power supply for the comparator transistor as we compensate at Zener. So it'll be quite interesting. I'll be back in about, I don't know, 15 minutes, but for you guys it'll be a second. Alright, I'll set the phone up in the tripod so you can see the scope, and I've tried to lock the focus and brightness so that you can make out the numbers on the scope. I know it's kind of blurry, but that was actually the best I could get it. So I mean, you can just make out that it says UV, and you can see it's around 290 microvolts RMS, and the peak to peaks. Yeah, that's as good as I'm going to get it. All right. Let's try and move that in view. That's the best I'm going to get for having both in view. Alright, so currently we're looking at the output of the supply. First thing I want to have a look at is the Zener on the what do you call it? The voltage doubler. Yeah, so the filtering after that's already doing enough of a job, so looks like we're not going to need one there. I had a feeling that would be the case, but I still left the holes there just in case. So what will be important will be what we're going to do now. I've got to think about a good way about going about this. What I'll do, I'll start with a disc ceramic because it's got a fairly high ASR. It's like having a resistor in series with it. And I'm just going to hold it across the positive feedback straight to the base of the comparator. Okay. That's 100 nanofarad. This is 1 microfarad. Now, adding 1 microfarad there would completely screw up the what do you call it? The response timing of it. What about just across the diodes? Nice. Okay. By the way, I'm using a MKT for this because this has got a low ESR at high frequencies and it's a Zener diode. So we want the low ESR, we want the high frequency response. I'm just trying to think. Yeah, no, that shouldn't hurt the response timing, I don't think. Let's just hook this up. Is that on screen too? Yeah, cool. Right. No, that doesn't hurt the response timing of it. If I short the output quickly, does the voltage come straight back? Yeah. Alright. See, if you put the 1 microfarad between the output and the base, what happens is you essentially, every time the voltage on the output changes, you got to wait for the capacitor to charge up to the voltage differential between the base and the output before the base will see the change. So the bigger the capacitor value, the slower your feedback time will be. So if you put 1 microfarad or 2 mic there, around about that, probably on a design like this, you could end up with like a second of delay, literally. What I mean by that is you could put a short on the output, it would drop to say 0 volts, and then as you took the short away, you'd watch the voltage go 1, 2, 3, 4, 5, 6, 7, 8, 9, back up to 18. It wouldn't just go bang, 18. So I'm happy with the 1 mic for the Zener. Well, you know what? I've got a 10 microfarad monolithic cap here. Let's just see if that makes much of a difference. No. Let's just see what 100 nano does, but again, MKT. No. So I'm going to use a 1 mic for the shut up cap for the Zener. I think I will just, out of due diligence, put a 1 mic cap on the other Zener too, because I know it will get rid of the Zener noise, and when this thing gets loaded down and the comparator transistor is drawing more current through that Zener regulator, there is a possibility that some of that noise will end up on the collector of the comparator transistor and then end up on the output. So I'll put a 1 mic there and a 1 mic on the feedback Zener. So that's those two values. Why is there another capacitor over here? Okay, I just found the random capacitor on my bench this morning. I found a 560 ohm resistor at my front door, 1/2 watt metal film. My cats have been up to stuff. So we also have a Zener down here on the emitter. So let's, now that gets noisier. Let's put this one here first and leave this here. Because it's hard to see a signal through a bigger signal. No, that does not want a capacitor across it at all. Alright, so I'll go with 2-1 microcaps. I'll just do something else, just to show you what I'm talking about here. I'll unplug this, and I've got a regular probe here, not modified to be soldered up really close to something. And I'm just going to put this on, if I can get to it, the output of the Zener that is at the voltage doubler. Now I've just got to find ground. Now, try not to worry about that ripple, that's because we're before the filtering. I'm not going to be able to see Zener noise through that. Let me have a look on the output of the filtering, because if it's really not that much of a problem, I won't put the 1 microcap there. Alright, now we can see stuff. Let's try 1 microcap here. Yeah, I'm not seeing a difference. I'm just going to turn the voltage all the way down so that the comparator is essentially pulling more current through the circuit. We'll have another look. You know, I think I'm actually going to leave that one out. That's actually not making a difference even when I look right on that circuit, so I'm not worried about that. I'm still wondering about the Zener that's in the emitter leg. I'm just thinking. I might just clip onto the output the other way around. Put my tip on the negative, and, well, actually I need to unplug this first, otherwise we'll be shorting out through the scope. Just want to look the other way in case some common mode noise is obscuring the noise I'm trying to see, if that makes sense. Yeah, I think it is, because now I've clicked on the other way around. Oh, there's nothing plugged in. I was going to say, that's awfully quiet. 50 microvolts. It's like the full-on nice supply that I'm building. Alright. Let's chuck a mic across this Zener. No. Okay, let's try 10 mic. No, I'm not seeing a difference there. The other thing I was considering was still putting one there anyway because, well, that Zener is acting as a reference, so I would imagine having a capacitor on it will make it more stable. Small fluctuations will have less of an effect on the Zener voltage. It'll take a bigger fluctuation in current and voltage over a longer period of time for the Zener voltage to change if there's a capacitor across it. However, we don't want to add more noise to the circuit. So let's just, I'll just grab that 10 mic again. It's disappeared, I don't know how. Here it is. Alright, I'm not seeing a difference. What I'm going to do, because it's in a feedback path, it is on the emitter leg, so it's got the rejection from being in the emitter path from that transistor, and it also then goes back through. You've got to think about the AC characteristics of a DC circuit sometimes, you see, well, all the time. It's also going back through the load resistor, load capacitor, output capacitor, sorry, and then on the feedback where the diodes are, we have this capacitor here, which also improves our AC feedback. I think what I'm going to do, I'm just going to pause. Oh, I don't need to pause the video, I've got them right in. Grab a couple of crock leads, and I'm just going to attach some crock leads to the output of this. And I'm just going to grab a resistor. One moment. I'm just thinking maybe about 20 ohms, something like that. I've actually got a 10 watt 10 ohm resistor, that'll do nicely for this. I'm just going to chuck that on the output. Okay, so you see those spikes on the screen? Yeah, you do, cool. I just had to look at the camera because sometimes it doesn't see small spikes. I have to zoom in more. Let's put a cap across this Zener now. Spikes don't change. Okay, let's put a cap across this Zener. Spikes don't change. Nothing changes. Alright. I'm going to solder this one mic in. I'll take this load off. I'll solder this one mic in. Let's turn this off. I'll solder this one mic in, and then we'll have a look at AC feedback circuit between the output and the base terminal. The reason why you start compensating or trying to shut up the Zeners first is because, as I mentioned before, the larger the value of capacitor that's on that feedback path that I'm talking about between the output and the base of the comparator transistor, like I said, the more it slows down your response timing, right? So if you can compensate or quieten up the Zener as much as possible first, that leaves you a lot less noise to have to get rid of, and then you can use a much smaller value of capacitor and a higher value of resistor between your output and your base junction without hurting your response time. This is why I wanted to do this little video series, because it's, I don't know, I enjoy building stuff, and you know, yeah, you make mistakes along the way, but I don't edit them out, and I'd rather talk about them so people get an idea for what's going on when they're building something and something doesn't seem to be working out as they expected. power back up. What we're going to do now, I'm going to start off with 100 nanofarad cap, which is way too big for this, but I want to see if there's any appreciable difference. Because if there's no appreciable difference with a 100 nanofarad cap straight across the output to base, I can tell you now that anything smaller is not going to make a difference. Hence, there's no need to even add this network. Because the pot is only 5K, and we have a capacitor across the diodes on the positive half of the feedback network, there's enough AC feedback through the lower, if you're using a 50K pot, for example, you might need to add some capacitance in the feedback line so AC can get back. But the important thing of AC feedback is, think about it like this. If whatever you've got hooked up to your supply, it's inductive or whatever, it's pulsing, every time its polarity sort of reverses and you get a negative going spike coming out the positive wire back into your power supply and vice versa on the negative wire, if your AC feedback in the power supply is poor, the comparator won't see that reverse voltage and try and output more current to compensate it, and vice versa. So you'll have poor regulation in the AC world, if that sort of makes sense. It's a bit hard to explain. So that makes absolutely no difference there. I'm just going to turn the voltage up all the way to 18 because that means that there's now a different resistance between the base and the output. Essentially a higher resistance, which is where we could run into issues and need to couple it a little bit. So we'll see. I have a feeling 5K and a 1 microfarad cap across the Zenas will be adequate enough to provide good AC feedback, but let's see. I'll just wait for that to come. I'll just move it down. There you go. Let's have a look. No difference. Alright, I'm going to put the load back on. Gotta be quick. No difference. Alright, that is it. So no more components are going to be added to that board. Well, actually, that's something I've got to think about. I'm going to pause the video and do a little bit of research. I've got a few publications on my computer from Agilent and companies like that for power supply design and stuff like that, and just to highlight at different topics. I just want to go do some research because obviously if you put a capacitor across the Zena, it's going to make the voltage more stable with fluctuations. But what I'm wondering is, because it's in the emitter path, essentially in series with a resistor in series with the output, it has the capacitors in series. Hold on. Right, sorry about that. I just heard this thud sound, and it sounded like one of my cats was climbing up the door, possibly in between. Two of my doors have a gap that's like this wide between the wooden door and the screen, and one of the little kittens always manages to sneak in there as I shut the door. I don't know how she does it, because like I literally look and I see her the other side of it. I'm like, right, you're out the way, and I quickly shut the door, and then half an hour later I'll hear a meow or just this metal sound, and I'm like, you're kidding me. Open the door, there she is. Anyway, yeah, I'm not going to deny this. I've got to do some thinking. If I can't come up with a good... Actually, no, I think I've answered my own question, because, yeah, although it's in series with the emitter and the output, it does have capacitance kind of across it. It also has active components in series with it and a varying load in series with it, which means no, it doesn't. It's not like the same as having capacitance across it. So now what I'm thinking about is using a smaller value cap, because we all saw without the feedback here that leaked some noise. So I'm thinking I might just put 100 nanofarad there. I think I'm going to pause the video, do some thinking so I don't waste your time, and I'll come back and tell you what I decide to do, and I'll show you obviously at the same time, and then we'll update the schematic too. Alright, I'm not going to lie, I did have a quick look online as well as having a think to see if I could find anything, and I couldn't really find anything in the quick look I had. But using my login, here's what I think's going on. Because when I added capacitance across that Zener that's in the emitter path without a capacitor in the positive going half of the feedback path, we saw more noise. But what I think that is because I'm adding a capacitor across that Zener. I think, I could be wrong, but I think it's shunting the AC noise through the pot and then back into the base of the comparator transistor. Because how do I explain this? Because there was no capacitor across the positive half, I think the noise was going back in phase and then getting amplified, but because there's a coupling capacitor across there now, I think it's either sending the noise back out of phase and it's cancelling it out, or it's shunting it. I'm not sure which of the two. I'm not going to lie, I'm a little bit confused. I think what I might do is grab let's pause the video. I'm just going to go grab a big capacitor. I doubt this is actually going to do anything because it's an electrolytic capacitor and it's really high frequency noise, but so I don't think it's actually going to pass anything. I just want to see if it looks noisier with 100 mic across it. It really doesn't seem to make a difference. I think I'm just going to put 100 nano there, just for some high frequency stability for the Zener itself, voltage wise. What I'm saying is so that for small fluctuation changes, you know, like when there's inductive loads and such on the output, so that the Zener voltage doesn't want to jump around so much. So that's what I'm going to do. So 1 mic MKT for the feedback on the positive half, and on this Zener here, I'm just going to put a 100 nanofarad MKT. Soldering iron went to sleep. I'll just pause the video for a sec. Alright, soldering iron's heated up. Did I turn this off? Oh, thank God. I looked at my meter and saw zeros and I was like, oh no, don't tell me I left it on, and I just popped it because it's still plugged into the scope. As long as it's either turned off or it's unplugged from the scope, I can solder on it whilst it's on. Or on and unplugged from the scope, or off and plugged into the scope. Anyway, you know what I'm trying to say. Alright. You know what? I've got heaps of them. I'm going to put a 105, a 1 mic. I'm just going to use one of these little mono caps because they're cheap across that first Zener. because it's not only across the Zener, but it's actually also across the output of the Zener, which comes off of a voltage doubler circuit, and one leg of that is just AC. It's going through half-wave rectification, sort of getting doubled. I don't know. I just feel like if there's some noise on the grid, high frequency spikes, or a load that's supplied down, maybe, just maybe, this might have a little bit of an effect of filtering it out. It ain't gonna hurt it being in there. It would just be a waste of a capacitor if it's not ever going to do anything, but it's not going to hurt it. Alright. So, now what we need to do is we need to look at building a common mode suppression network for the output. So I'm going to take these alligator leads off that I'm using for the load resistor, and I'm going to get two shorter ones. I'm going to hook these up to the output. Okay. Now what I'm going to do is I'm going to take, I need to go get another 100 nanofarad cap. My apologies. MKT 100 nano, that is. Why is it that things just disappear when I need them? God, hang on, I've got to pause the video. Makes sense. I had 104s in two different drawers and they were the same capacitor, so I realised that and changed it. That's why they went in the drawer I thought they were in. Alright, so what I'm going to do is I'm going to join the two capacitors together like that and hook the output up to each end of it like so. Right, and I'm going to take a third alligator lead and clip it onto this middle point where we want to join the two capacitors together. I'm just going to place this down on the bench, and now with this remaining end, I'm going to take this back and clip it onto the chassis. And I don't see any difference at all with 100 nanofarad capacitors, which tells me, because there's a bit of peak to peak noise there, but it's quite high frequency. Just out of curiosity, I don't see going up to one mic making a difference. I mean, it is going to shunt high frequency noise to ground more, but we don't really have common mode problems here. This is high frequency stuff. But who knows what's also getting leaked through the grid. So let's just have a look, see what one mic does. Yeah, bugger all. Let's turn the voltage down. Okay, so that's with it grounded. Yep, takes a bit off. Let's go back to the 100 nanos and see if they're enough. Whoops, I just shorted the output. Let's just see if the 100 nanos are enough. It all depends on how much ripple current there is, you see. Not a huge effect, but nah, going to go back to the ones. Yeah, I'm happy with that. Peak to peak 1.34, 1.3 millivolts peak to peak, 62, 65 microvolts RMS at the bottom end, unloaded, and at the top end that is 1.9, 2 millivolts peak to peak. Actually, it's less than 2 millivolts. It's around 1.9 millivolts, 1.86, and 140 microvolts RMS. So we've got quite a quiet supply here. You've seen it loaded down. It doesn't get much noisier. All right. Time to put all this. Oh, you know what? Actually, there's still another trick I got up my sleeve I forgot about. Sometimes adding some resistance to the common mode network on the line that goes back to ground actually helps also. I'm just going to turn this back down where we can see more of an effect on it. The reason we can see more of an effect because there's less noise when it's turned down, and we can see smaller signals with better integrity when it's not masked by a bigger signal. I'm just going to add a 100 ohm resistor in series with this to the chassis and see if that is better than just directly shunting it to the chassis. That's 100 ohms. That's direct. Looks like direct in our case. Oh. Yeah, direct. Okay, cool. So now we know everything we need for this thing. Let's go finish putting it together. Alright, I thought I'd just give you guys a quick look at the setup because I realised the way I had the camera looking at it, you could just see what I was doing to the board barely and the scope. So yeah, I just had my little probe still soldered up the way you saw me do it in the first place. That's going off to the meter up there so you could see the voltage, and the pot's still hanging off the side, and those are our extra components: 1 micro mono, 100 nano, 1 mic MKTs. And as you can see, there's those 4 diodes there going from emitter to base on the comparator transistor 41N4148s. 1N4148s in series, pointing in at the base, and the 1K resistor with some spaghetti tubing around it because I screwed something up and had to move it. And yes, I took that little wire link out. Yeah, so all we have to do is solder these across the output, like negative, positive, and the center point goes back to ground. Same with that goes across the output. 2 wires are your source wires, 2 wires are the sense wires. And I was going to make up a board for this, but I don't know. I might do it, I might not. If I do, I'll post a little video just etching the board and I'll add it to the PCB etching playlist. Otherwise, I might just wire wrap the components around the end of these connectors and solder it to it. The problem with these is you can melt the plastic if you get it too hot for too long. But I don't know, shouldn't there be more nuts with that so I could make a board and screw it? You'd think you'd be able to screw it. Maybe it's me, maybe I'm missing something. How do they come? Oh yeah, right, so I see. Yeah, it only comes with the 1 nut, but you're supposed to screw it in between a board, I see. So you don't have to solder to it. But it's funny because it's got this little head on it. Sorry, if I can get this to focus. Like it's also made for both. I don't know. I'll have a crack at it. Clearly I've got plenty of these ones. They're only the crap ones. These are the good ones. So I'm not worried. I'll have a go at soldering it. If it melts it, so be it. And I'll just make a board up. But yeah, this video has gone on for long enough. I don't want to bore people. So what I'll do is I'll just put the schematic here and make the appropriate updates to it. I just realised that wouldn't work either. Not that I've added fallback current limiting to this power supply anyway, but I'd hate for people to look at my notes and try and learn something and it doesn't work because of me being a dumbass. I shouldn't have drawn that there either. I guess the way this would work, I can't even think right now. I know this is very crude, but very crude, but yeah, that's how that would work. I still feel like I've done something wrong. No, that's right. Yeah, that's right. Anyway, that's not what we're here for. So what I've done is nothing there. Straight through. Oh no, these are 1 UF. Incidentally, I've used 100-volt capacitors. $100-volt 1 UF. We didn't end up needing this compensation network because there's enough low resistance with the 5K pot and the cap across there to get the AC back in the base here. So that's it. I'm not forgetting something else, am I? Yes, I am. Our Zener here also has a capacitor across it. And there's no other 1 microfarads in here. Okay, so that is the final schematic. Obviously it's not going to change now because it's built and it works. So that's the schematic, sorry. That is the final updated schematic with the compensation components added for the actual power supply. And then This is the updated schematic for the power supply that feeds the power supply. I always find that funny. To build a power supply, you need to build a power supply. Alright, that's all for this video. Incidentally, I am going to build this tonight, so the final video for this will be uploaded tonight. And guess what I'm starting on then? This. And I've had to think about this since the last video. This has only got a single rail supplying it. It's a differential amplifier. I might end up changing this a little bit. I haven't even looked up the data sheet. I don't know if there's a reason for this, but I'll find out. I'll do my preparation, of course. Might end up changing this to a differential power supply. I don't know. But this project's coming up straight after this, which is basically finished now. All I have left to do is cut out a hole and solder a couple of wires, capacitor, resistor, 3 capacitors and a resistor. That's it. Alright, thanks for watching. Please, if you like my content, like and subscribe, and I'll see you on the next one.